Alright then, hopefully the videos are turning out to be helpful so far. I was thinking I'd just try one more for now. It's going to be one of these ones involving the polarimeter. We've already done a whole bunch of them, so I don't know if everyone's already an expert or what, but just in case anyone wants to review anything, I thought it would be good to try one, because you can be pretty much guaranteed you're going to have one on the exam. Okay, so I made this one up. Hopefully everything works out. We've got 5 grams of a single enantiomer of an unknown compound, and you dissolve it in enough methanol to make 10 milliliters. Okay, so the first one sample's got 5 grams in 10 milliliters. That's 0.5 grams per milliliter. And what's that give? That the polarimeter reading in a 1 decimeter cell is 28. That should read degrees. Plus 28 degrees. Okay. Then the second sample says 8 grams of the sample is dissolved in 10 milliliters of methanol. So that's 0.8 grams per milliliter. And what's that do? That gives a reading of minus 64 degrees. What's the specific rotation of the unknown compound? Okay, so right now, as usual, we're going to have to realize that neither of these values is necessarily the optical rotation alpha, just because it's what we're getting on the polarimeter. Actually, we know that at least one of them is not, maybe both, because if it's a single enantiomer, we can't have a plus 28 for one reading and a minus 64 for another be the alpha, because they should either both be positive or both be negative. But it's also possible that neither of these is really the value. So let's do this. We've got 0.5 grams per milliliter and 0.8 grams per milliliter, and the 0.5 one's plus 28. So we're considering anything that's plus or minus 180 or any multiple of 180 from plus 28. Okay, so what's that do? Plus 28 plus 180 would be plus 208 degrees, plus another 180 is plus 388 degrees. Okay, and then if we were to subtract 180, we'd have minus 152 degrees, or another 180 would be minus 332 degrees. Okay, and then with the other sample, we had minus 64 degrees. So plus 180 would be plus 116, and another 180 would be plus 296. Minus 180 would be minus 244, and another 180 would give 424. Okay, so hopefully you can set that up easily enough. Now we just have to figure out what's the actual value of alpha that we're looking for. So just to get an idea, we know that the one that's 0.8 grams per milliliter is more concentrated, so it's going to rotate the light more. But how much more? Well, 0.8 over 0.5. What is that? 8 over 5 is 1.6. 1.6. So we're looking for a value in this column that's 1.6 times the one in this column. So times 1.6. Alright, so what if I took the plus 28 value? What is that times 1.6? 28 times 1.6 equals 44.8. Let me write that down. 28 times 1.6, 44.8. Is that in this column over here? No, not at all. Alright, so that's not going to be one of the values. What about the 208? 208 times 1.6. 208 times 1.6 equals 332.8. Okay, and again, we don't have a 332.8 in this column. Okay, even if I were to add another 180 to 296, I can see right away it's not even going to be close to 332. Okay, so that means the 208 value is not good. And also, I can rule out these ones over here because we've passed them. 208 times 1.6 was 332, which is higher than the plus 96, or plus 296. So I'm going to start looking at the minus values now. How about the minus 152? Minus 152 times 1.6. Well, that gives 243.2. Okay. So negative 152. Sorry. Times 1.6 equals negative 243.2. Okay, well, that seems to be working pretty well. These two seem to match up. Okay, so let's go with those. That means for the first sample, we have alpha is equal to negative 152 degrees. Okay, so we're looking for the specific rotation. That's alpha in brackets. So now we simply have to remember our formula was alpha is equal to, it's dependent on the type of molecule we have, how much of it we have. Bigger C will make it bend light more, so we're multiplying times C, not dividing. And then the longer the sample tube, the more it will rotate light. So again, multiplying by the length. All right. And then if we're solving for alpha in brackets, we have alpha is equal to alpha, the specific rotation is equal to the optical rotation divided by the concentration times the length is equal to, we said, minus 152 divided by, what was the concentration of the sample with the negative 152? That was 0.5. And then the length was 1 decimeter. Sorry. So negative 152 divided by 0.5, that's going to be what? 304. Okay. So that's our answer for the specific rotation.